acara hari ini itu akan dimoderatori. Mungkin sudah familiar ya dengan Bu Devi Pramesti. Beliau adalah merupakan dari PT Pusat Pelatihan Kompetensi Mandiri dan Material serta Welding Expert di PT Pusat Pelatihan Kompetensi Mandiri. Kemudian sebelum kita mulai, mari kita masuk ke agenda pertama. Kita buka dengan doa. Waktu berdoa dipersilahkan. Oke, selesai. Udah acara selanjutnya adalah pemaparan. Baik, halo Mbak Devi, sudah
Ya,
ready kah?
halo. Baik, terima kasih Pak Yusuf
Baik,
atas
silakan Mbak Devi.
kunjungannya. Terima kasih rekan-rekan yang sudah hadir hari ini. Kita berjumpa lagi di webinar session kali ini bersama Welding Study Center. Di sini kita sudah bersama dengan speaker dari PT Bohler, Pak Rosan Rampure. Selamat siang Pak Rosan, terima kasih telah hadir. Ya, kepada semua peserta, hari ini kita akan membahas berdiskusi tentang how to select welding rod, electrodes, and filler metal. Maka siapkan Bapak-bapak dan ibu-ibu jika ada pertanyaan di pertanyaan session Q&A nanti di akhir acara. Sebelumnya, saya akan memperkenalkan Pak Rosan Rampure ini sebagai International Welding Engineer dan Metallurgical Material Engineer juga, dan beliau juga sebagai application dari Welding Engineer di PT Bohler. Beliau memiliki background Metallurgical and Material Engineer dengan berpengalaman lebih dari 15 tahun dan juga sebagai aplikasi Welding Engineer yang berpengalaman terkait dengan proses SMAW, GTAW, GMAW, FCAW, SAW, dan ESSC. Kemudian juga brazing dan WAAM. Nah, kemudian beliau juga sekarang menjadi production manager di PT Bohler dan juga beliau memiliki background sebagai Bachelor of Technology in Metallurgical and Material Engineer. Baik, saat ini sudah kita hadirkan Mr. Roshan. Kita mulai saja sesi untuk materi kita hari ini. Sebelumnya mohon di mute terlebih dahulu untuk masing-masing Zoom Bapak dan Ibu supaya tidak mengganggu berjalannya acara pemberian materi. Kemudian nanti setelah pemberian materi selama 45 menit ke depan, kita akan ada sesi Q&A. Setelah itu kita ada kuis, ada 3 pertanyaan di mana yang dapat menjawab kuis tersebut kita akan berikan souvenir. Kepada Pak Rosan, silakan waktu dan tempat kami persilakan untuk memberikan materi selama kurang lebih 45 menit ke depan. Please welcome Mr. Rosan to give the material for this topic.
Thank you so much. Good afternoon, everyone. My name is Roshan Rampure, as already introduced by our moderator and Payesu and Refi. I am currently working as an application welding engineer in hostel pin and boiler welding. By education, I am a metallurgical and materials engineering because I did my Bachelor of Technology in Materials and Metallurgical Engineering. And by experience, I have worked as a welding engineer in different organizations for more than 15 years now. And I really thankful to WSC to give me an opportunity to present this topic to you. So let me start and let me share my presentation. Okay. Okay. I hope you can see my presentation screen.
Yes, clear, sir.
Okay.
Yes, sir.
Okay. So let's start the topic. The topic of today's webinar is selection of welding consumables. As I have introduced already about my introduction. So the basic points covered in this presentation are like importance of selecting a welding consumable, what are the different types of welding consumables, specifications for welding consumable, and what are the testing and quality assurance requirements for welding consumables. So these are the main topics for a discussion in today's webinar. And to support these main topics, I have also included few subtopics which are necessary to come up to these main topics. So let's start with the basic. Just brief introduction about different basic concepts in metallurgy and welding. So about different classifications of base material. So what are different types of materials? Okay, we are here talking about metallic material. We are not talking about non-metallic material. So in the metallic material, there are basically two categories. One is ferrous alloys and one is non-ferrous alloys. The ferrous alloys, as the name itself suggests, that these are basically iron alloys. Means ferrous alloys means the majority of the elements present in these alloys is iron. Okay, and non-ferrous means other other elements are present as the main element, like maybe copper or maybe aluminium or maybe cobalt or maybe nickel. So these are non-ferrous alloys. What are different types of non-ferrous alloys? One is the nickel base, then another one is aluminium is the main element, then copper, titanium, then again there are different grades like cobalt alloys. So these are basically few categories or the few types of non-ferrous alloys. Okay. So now coming over to ferrous alloys. So the main subcategory of ferrous alloys is one is unalloyed material or unalloyed ferrous alloy we can say, or unalloyed steel we can say, and another one is alloyed one. So unalloyed, as the name itself suggests, there is no alloying as such. So it is basically no alloying addition is done in the iron or steel. Whereas in the alloyed category, there are low alloyed and high alloyed. So basically, the low alloy and high alloy are roughly classified based on the percentage of alloying, means how much the alloying elements are added to steel. So based on that, low alloy and uh, high alloy are categorized. So in low alloy and high alloy, there are different subcategories like high strength low alloy, okay, then creep resistant chrome moly material. So different categories are there. And high alloyed means the alloying addition is generally more than 10%, then it is considered as high alloy. So main categories are including stainless steel or nickel containing alloys and materials. Okay. So now when we come to basically we'll be talking about our steel material. So what is steel? Steel is a material which is an alloy of iron and carbon. Okay, so steel is nothing but majority. It's when we add some percentage of carbon to iron, it becomes steel, and the maximum percentage of carbon which is allowed in steel is 2.06%, and beyond that it becomes cast iron. So if you are aware about the iron carbide diagram, then you are very well aware about the categorization of steel and cast iron. So why do we add carbon to iron? Because carbon increases strength, hardness, and the practical applications of steel are much more as compared to pure iron, because pure iron as such has not much practical application. So carbon is added up to different extent to get different properties. Okay. So basically steel is unalloyed material, but in the practical application, there is no steel without any alloying addition. I mean, there may not be any material grades which just has iron and carbon into it without any other elements. Okay. There are, what are the other elements present? One is contaminants. So what are the contaminants? Because steel is produced by steel making process from the iron ore. Then by refining process, it is converted into the usable form of steel. So during the refining, there are still some level of contamination depending upon the acceptance criteria. And what are those contaminants? Some are permitted contaminants, which are necessary up to certain extent to have certain properties of the steel material, like manganese, silicon, and aluminum. These are generally deoxidizer elements which are added during the steel making process. And these are also present in the final steel up to certain extent depending upon the type of steel we are using. Then non-permitted contaminants, we should not say non-permitted as such, but they are present up to certain extent. We can remove them 100%, but removing to the lower and lower percentage, it needs multiple refining processes or the longer refining time, which increases ultimately the cost of the material. So up to certain extent, depending upon the application and requirements, these phosphorus, sulfur, oxygen, nitrogen, and hydrogen, these elements are left as it is up to certain percentage level or up to certain ppm level for nitrogen, hydrogen, and oxygen. Okay, and phosphorus and sulfur are also limited up to certain extent. So these are non-permitted contaminants. Then now the fourth component is the alloying element. Can you mute? Someone is having a noise.
Yes, yes.
Okay. So why do we do alloying? As such, when we say manganese and silicon, we do not say these are alloying elements. These are basically a part of steel itself, which are inherently present in the steel. But alloying elements are those elements which are deliberately added to the steel to get specific properties. Like, say for example, when we add, okay, chromium is added to get higher strength as well as to get the corrosion resistance. Moly is added to get the oxidation resistance at higher temperature. Okay, likewise, different elements are added in a different combination to get special properties. What are the special properties? Because for practical application, we need high strength, high corrosion resistance, higher impact properties. Okay, so for the particular use, we add a combination of alloying elements into the steel. Okay, and based on that, different types and categories of steel grades are available. Now, when we talk about the material or the ferrous material, or when we talk about steel, the majority of joining is done by welding. Okay, so most of the steel materials are nowadays majorly joined together by a process of welding. So what is welding? Most of you may be aware about what is welding. Okay, you might have been doing it on your regular day-to-day job, but the book definition of welding is this: it's a joining process in which two or more parts are united or joined, producing a continuity in the nature of the workpiece material by means of heat or pressure or both, and with or without the use of filler metal. Now there are different numbers of different types of welding processes depending upon the source of energy, like whether it is heat or whether it is pressure or whether it is both combination of heat as well as pressure. So most common is the arc welding process. Then there are resistance welding process. Then there are solid state welding, brazing, oxy-fuel, soldering. All these are brazing, soldering. These are all joining processes or the welding process, we can say, as a broad category. Then most practical applications for welding are the arc welding process, and that too there are few welding processes which are very commonly used in welding industry. What are those processes? These are the processes like SMLW, shielded metal arc welding, GTAW, GMAW, FCAW, and submerged arc welding, SAW. So in this topic, we will be covering this 5 process in little bit details. So coming over to SMAW process. SMAW it stands for shielded metal arc welding, or also known as manual metal arc welding. So what is the main consumable part is, it is a stick electrode, or it is called electrodes. These are normally available in 2.5, 3.2, 4 millimeter and 5 millimeter diameter. Length varies from 250 millimeter all the way up to 450 millimeter. So this is the photo where you can see the typical welding electrode. Similarly, GMAW is gas metal arc welding. This is a gas shielded welding. Okay, also called as MIG or MAG. Whenever there is a inert gas used as a shielding medium, then it is MIG process, or metal inert gas arc welding process, or if the active gas is used, then it is metal active gas welding process. The different types of spools are used, or diameter of the wires used are 0.8 all the way up to 1.6 and 2 millimeter dia. Most common form is the plastic spool or basket spool, are also available in the drum packing. Okay. The next is flux core arc welding. This is a variant of GMAW process itself, and the main difference is this is in the GMAW process, the spool or the wire is a solid wire, whereas in flux core arc welding, wire is a tubular wire. Okay, that means the flux powder is present inside the tube or inside the wire tube. The variant of this process is MCAW, in which the wire, instead of having flux powder, there is a metal powder inside, which is called as metal cored wire. Then this is the next process is GTAW, gas tungsten arc welding, in which the filler rod is acting as a filler wire. It is not an electrode, because unlike SMAW and GMAW and FCAW, in those processes the wire or the electrode itself is acting as a electrode, means the current is flowing through them. Okay, whereas in GTAW, the tungsten electrode is the non-consumable electrode in which the current flows, whereas the filler metal or the TIG rod is added as a filler rod. So the current does not flow through the consumable part. So that is the difference between the consumable electrode and non-consumable electrode. The dimensions for this is generally used in 1000 mm length, and diameter of the TIG rod is generally 1.6, 2.0, or 2.4. Bigger diameter and smaller diameters are also available. For the automatic TIG welding, it can also be supplied in the spool form. Now the next process is submerged arc welding. This is a arc welding process which is most commonly used in fully automatic form, means the travel speed as well as the feeding of the wire itself is automatically controlled. And the submerged arc, as the name itself suggests, the arc is submerged under the burden of the flux. So there are two consumable parts which are supplied separately. One is the SAW wire and another one is the SAW flux. Okay, so flux is an important part in this process, and most common welding position in which the SAW process is used is flat, and in certain applications in horizontal position. Now, when we talk about the welding position, there are different welding positions classified as per EN/ISO as well as ASME code. So when we talk about ASME code and EN/ISO, there are different types of positions or different nomenclature for different positions in which the welding can be carried out. Like the first photo here is mentioned as PA position, which is a 1G position. That means when the electrode is held vertically and the plane of the base material is horizontal to the ground, and the welding is carried out from the top. So this is a flat position or 1G or PA position. Similarly, 2G is a position in which the plane of or the axis of the plate is vertical to the ground, perpendicular to the ground, and the welding is carried out from side to side. In the similar way, 3G position or PG position is the vertical down position, and another variant is vertical up position. Okay, as you can see in the photo. Then there is the overhead position, in which the flat, if you convert the 1G position and rotate it by 180 degree, the plate will become overhead and the position will be carried out from the below. In the similar way, there are welding positions for pipe, okay, 1G, 2G, 3G, and 5G and 6G positions are there. In the similar way, the fillet positions are also classified as 1F, 2F, 3F, like that, also for the pipe. Okay, this is just for your reference to know about the welding positions. Now coming over to our topic of why do we need a guideline or a topic to understand the selection of welding consumable? Because in most of the applications we do qualify our procedure, but what is the basic of choosing a right welding consumable? So the first and foremost important criteria is the application's requirement. And application requirement depending upon what component we are going to fabricate and what is the material selected for that particular application and component. So the first selection criteria for any welding consumable is based on the material's compatibility. Okay, so there are different welding consumable, different grades, different types, and which are designed for joining of matching or compatible base material. So selection of right welding consumable for right base material to ensure that we get the correct joint integrity as well as fusion with the base material is very important to get the integrity of the whole structure. So first and foremost is materials compatibility. Then next we will talk about the mechanical properties of the base material and its matching welding consumable. So whenever we select a welding consumable, depending on the base material mechanical properties, it should be matching mechanical properties. In most of the cases, slightly over matching welding consumables are used for a particular grade of base material. Then next is the chemical composition of the weld deposit using any welding consumable should be as close as possible or slightly overmatching in terms of the chemical composition of base material. Then welding process suitability, like whenever we select the welding process depending upon the application and the component and the base material, the welding consumable should be having optimal welding performance. Okay, and it should have a right compatibility when we are doing welding for that particular welding process, and the matching filler metal should be used to have a suitability for the welding processes. Next is welding position. So say for example, when we use one particular type of electrode, so some types of electrode, they are used for some particular welding position, but not suitable for any other welding positions. Like say for example, some type of electrode, they are designed for vertical down position, but not all types of welding electrodes are possible to weld in vertical down position. Okay, likewise, it should be all position electrode, not only for flat and horizontal position. So depending upon the welding position you are going to use, welding consumable has to be selected. Then next point is ease of use, because the welding consumable should also be selected based on its weldability and suitability for that particular application, depending upon how easy it is to use. So there are all other properties are matching, but ease of use, say for example, for rutile type of electrode is better as compared to basic type of electrode. Then that particular rutile type of electrode to be selected because it is more easier to use, more better stability of the arc, and very less pattern level. All those criteria also to be used because they will improve the efficiency of the welder as well as it will reduce the downtime. The next is the cost consideration. Of course, this is one of the most important criteria. If all the factors are meeting, then the more cheaper or economically viable option to be selected, because cost constraint, budget constraint is also to be considered. Okay, so I mean we can select a best product, but if it is not matching with the budget requirement, then there is no point of using the over matching or over selected welding consumable, even if other one is meeting the minimum requirement criteria. Okay, so that is also one of the consideration. Then weld appearance, the physical appearance of the weld deposit is also an important criteria, especially where the appearance or the weld ripples or the weld shining is important. There, this criteria also to be considered. Okay, now coming over to the what are different specifications of welding consumables. Welding consumables are classified as per different national and international classification specifications like AWS, ENISO, then there are other DIN or GIS specification. So different societies have their own specifications for classification of welding consumables, but most common in our day-to-day job work is AWS classification and sometimes ENISO classification. So AWS is nothing but American Welding Society, which assigns a specific code to welding consumable that indicates their type, their material compatibility, then its intended use. For example, AWS A5.1, it covers the SMAW electrode for unalloyed steel. Okay. Then material grade. The classification also includes the type of material for which the welding consumable is designed for. So for example, when we say ER316L, that means this particular filler rod or the wire is designed for joining of stainless steel 316L type of base material. Okay, then it also is classified based on the chemical composition, just like I said. Even for the nickel alloyed steel, they also have, or the nickel alloys also have the classification based on their composition, like NiCrMo3. So this NiCrMo, this indicates the main alloying elements. Okay. Then the tensile strength and yield strength are also important property based on which the classification is done. It also includes the elongation criteria. Then impact toughness is also considered for classification purpose in some of the specifications. Then welding position is important, like when we talk about the welding position for classification, specifically for SMAW as well as FCAW wire. Then 0 is generally indicated for flat and horizontal classified consumables, whereas 1 in the classification indicates it's all position wire or all position electrode. Then some products like FCAW wire are also classified based on the shielding gas for which this has been designed for. Like general designation for say for example FCW is mixed gas M21 or 100% CO2. So the classification will also have this indication of the shielding gas. Okay, then welding parameters like voltage, current, wire feed, travel speed, these are also to be specified because they will decide the deposition rate as well as the weld quality. Then certifications and approvals, different organizations, international bodies, regulatory bodies have their own specification for classification of welding consumables. So why do we need these different specifications? To have a uniformity across the regions or across the nations. So it helps welders and welding engineers and fabricators to select the right consumable type for their base material or for their welding application. So what are the different testing requirements for classification or to maintain the quality of the welding consumables? So basically there are two different types of material testing. One is non-destructive NDT, in which there is radiography, LPI, MPI, visual inspection and ultrasonic UT testing, in which the non-destructive means the material is not destructed as such, but the material integrity is as it is. Then there are destructive testing like in which the material is broken down to check the particular property, like tensile test. The tensile specimen is prepared, it is put into the universal tensile testing machine, and it is tested for the to determine the tensile properties including UTS, YS, and percentage elongation. Similarly, the impact specimens are prepared and the impact testing is done at different temperatures. Bend test, creep rupture test, hardness test, and metallography. These are some of the examples of destructive testing. Also, the corrosion testing, which is not mentioned here, also comes under destructive testing, but it is not a mechanical test, it's a corrosion testing. Then the testing and the quality assurance process for welding consumable are very important to make sure that they meet the minimum requirement for the classification or for the application, so that the integrity of the weld joint is maintained. And what are the different testing to be done or the criteria to be considered when we are saying that the quality of the welding consumable is met as per the requirement. So first and foremost is chemical composition analysis. For the solid wire, the chemical composition of the wire itself is determined, whereas for the electrodes and flux cord wire and SAW deposit, the weld metal deposit chemical compositions are determined. There are different methods used in the lab for determination of chemical analysis. Then there are mechanical testing, including the tensile test and impact test and hardness testing. So these are done to get these properties for the weld deposit. Then there are welding performance testing. This is done to make sure that the weldability or the usability of the product is as per the requirement. This determines the arc stability, then appearance of the weld bead, depth of the penetration, as well as the deposition rate during welding. Then measurement of the diffusible hydrogen content. Why it is important? Because most of the steel material, we do not need higher hydrogen content in the weld deposit, because if higher hydrogen is deposited through the welding consumable, there is a possibility of cold cracking or hydrogen induced cracking in the weld joint or HZ, and also in the base material. So the diffusible hydrogen content is determined, and based on that, different classifications like H4, H8 is also given to the welding consumables. There are different lab methods to determine the hydrogen content. Then microstructural analysis of the weld deposit also done to check the phases which are present, like ferritic phase, then benite, then martensite, or whatever the secondary phases are present in the weld deposit, that can be determined by microstructural analysis. Then corrosion resistance, different tests as per different international standards is conducted to check the suitability for any particular corrosive media application. There are also different tests involved for different types of corrosion, like pitting corrosion, the intergranular corrosion, crevice corrosion, and others. Then another quality assurance criteria is the dimensional inspection of the welding consumable. So when a particular size is mentioned, like 3.2 into 350 mm for the welding electrode, there is a tolerance level given in the international standards which need to be met for that particular size. Like it should not happen that 3.2 mm diameter is mentioned, but the actual dimension is diameter is 4 millimeter. So the selection of the welding parameter will also change accordingly. So it should be within the tolerance level. Then certification and compliance with relevant industry standards, then international codes and regulations, client specification also has to be met. And in many of the cases, the certificate of compliance is also issued along with the test report, the certificate, and traceability of the material also can be given. Then process control and quality management system is also to be checked. Like the most common quality management system is ISO 9001 2015. So these are some of the criteria which are to be tested or which are to be done to make sure that the selection of welding consumable or the welding consumable which is supplied is meeting the application's requirement. Now, as we have seen that in the previous slides, that there are different types of welding processes. There are different types of welding consumables for different processes, and other accessory consumables are also there. So based on the welding process, the different welding consumables are available. Like for process, electrode is present. These are coated electrodes used for SMW. The structure of the stick electrode is there is a steel core wire. On top of it, the flux coating is covered. Okay, so depending upon the type of the electrode, the composition of the core rod and the type of coating is different. So what is the main function of coating? It contains a mixture of flux. Basic function is it helps to shield the molten weld pool from the atmospheric gases and to stabilize the R. In some of the cases, it also acts as a medium to add the additional alloying elements from the flux. Then for GMAW or FCAW, the wire is called as these are solid wire as well as the flux core wire. So for me, TIG, these are solid wire. For FCW, it is a core wire or tubular wire. Then for submerged arc, there are two combinations. One is the wire as well as the flux. So they are fed separately, but in combination, they determine the properties of the deposited weld metal. So these are the welding consumables for different processes. Then for the gas-based process like GMAW, GTAW, and FCAW, there are different gas combinations available for these. Like for example, for TIG welding, most common is the argon. 100% argon is a gas used for TIG process. Then for GW, depending upon the type, there are different combinations like M21, C1, which is 100% CO2, or 80-20 mix of argon and CO2, as well as for stainless steel, there are different combinations like M12, M13. and like having 2 to 3% of CO2 or oxygen along with the argon mixture. So the shielding gas plays a very important role in determining the chemical composition of the well deposit to some extent, and to get the stable arc for these welding processes. So changing in shielding gas is also a major factor to change the weld appearance as well as the properties of the deposited weld metal. Okay, so the shielding gases are very important for, therefore the right combination of shielding gas is to be selected based on the material type as well as the process type. Okay, then the fluxes which are used for submerged arc welding and which are used for production of the FCAW are also of different combination. The fluxes are basically the minerals, oxides, silicates of different metals, and they provide the basic shielding, or they form the slag so that the molten metal is shielded from the atmospheric contamination. So depending upon the composition of the fluxes and the combination of different minerals, they are also subcategorized into different types. So this is the photo to show you the SMW process. You can see that the electrode is held in the electrode holder. So this is a cross section of electrode. The length is starting from the tip to the base of the electrode, and diameter of the electrode is considered for the diameter of the core wire, not for the total diameter of the electrode, including the shielding. So when you say 5 millimeter electrode, that means this core wire diameter is 5 millimeter, not the whole diameter of electrode including the flux. This is the diameter of the electrode. Okay. So what are the main tasks of welding? The flux in SMW electrode. This helps to have the shielding against the atmospheric air so that there will not be any contamination and porosity. Then it improves the welding behavior like the arc ignition, wetting properties, viscosity of the molten metal pool. These are also determined by the composition of the flux. It also helps to get higher recovery. Like say for example is 70-18. That 18 indicates that the iron powder is added into the flux so that we get higher recovery. So recovery here means when we talk about the total weight of the core wire and how much weld deposit we get in combination of the electrode as compared to the total weight of the core wire. It may be more than 100% also. So this also helps to determine the metal recovery. Then the slag which is formed during welding, it also helps in cleaning the molten metal pool. It produces the slag, and in the out of position welding, the slag provides the support to underlying molten metal pool to be in the place without causing any drop. So these are the basic task or the basic function of the coating, flux coating. Similar functions are applicable for the flux powder inside the flux FCAW wire also. So just to show you some of the applications of SMAW, of course, there are different processes that also can be used in the similar applications like structural steelwork, wherein SMAW, GTAW, GMAW, or FCW process can also be used. Then jack-up rigs also for the offshore applications. These are some of the examples along with the base material type ES690QL1. And the welding consumable which are used for fabrication of this particular grade was also mentioned here. Then pipeline welding, the most common type of electrode are cellulosic electrode used for cross-country pipeline welding. The reason being these are the cellulosic electrodes are having the higher arc penetration and they can also be used in vertical downward position without any problem with the control of the earth. So cellulosic electrodes are most common type of electrode used for vertical down position, especially for cross-country pipeline application. Then use of SMW electrodes for austenitic 300 grade series chrome nickel pipe welding in 5G and 6G positions. The SMW electrodes are classified based on or categorized based on different types of coating, and the types of coating are determined based on the components of the minerals which are used for production of those flux coating. So cellulosic type is the one, another one is acidic, or also similar is the rutile type, and another one is basic type. So cellulosic type, the main component is cellulose, and others are like TiO2, SiO2, FeMN. Whereas in acidic or rutile type, in the acidic one, magnetite, quartz, these are the main composition of the flux. Rutile is nothing but titania, which is TiO2 titanium oxide, which is the main component. And another is the basic type, in which the basic flux components are in higher proportion, like CaF2 is the main component, CaCO3 is the main component for basic type. So why do we need all these different types of coating? The one is the different applications, different requirements of the mechanical properties. Okay, say for example, the basic type is generally not suitable for welding in vertical downward position. Also, acidic and rutile coating electrodes are not suitable for vertical down position, but cellulosic type can very well be used in vertical down position. And why do we need vertical down position? Because the welding productivity or the speed of welding is more when we do in vertical down position. But there are certain improved version of basic type which are also designed for vertical downward position welding. Then another criteria, like say for example, when we talk about the stainless steel material used for cryogenic applications, the basic type has a property of purifying the molten metal to greater extent so that we can achieve higher impact properties at lower temperature up to minus 196 degrees Celsius. So when we talk of the comparison between basic and rutile type, stainless steel electrode, basic types of electrode, which is a dash 15 type, are more suitable for such critical applications, whereas rutile type will not be suitable for such critical applications, but for normal application where the impact properties are not that great, in those cases the rutile type electrode will be more suitable. But when we talk about one good thing, there's a trade-off between another property. So when we say basic type of electrode gives us much better mechanical properties, specifically impact property, but the negative side is the welding behavior. The molten metal pool control for basic is not as great as rutile type. The slag detachability, residual slag is not so good for basic type. Whereas for rutile type, the slag is easily removable. Whereas for basic type, you need to do some grinding or maybe use the hammer to remove the slag. Also, the build appearance for basic type will not be very good in terms of the aesthetic appearance. Whereas for rutile type, the build will be very shiny and smooth ripples will be or can be seen for the rutile type of stainless steel electrode as compared to basic type. So we have to choose depending upon the applications which type of electrode based on the coating is selected for any particular application. Okay, then there are certain mixed type also, like cellulosic rutile, wherein the combination of two types of coating components are used. So acid, the as per the normal nomenclature, A is used for acid, C for cellulosic, rutile for R. Then heavy thick rutile coated is double R. Rutile and cellulose coated is a combination like Ra, Rc, Rb, and then there is a basic coated electrodes. So talking about the AWS classification, say for example, we'll take an example of Buller Fox's E50-1. This is a brand name of our product, or we can say product name. The AWS classification as per A5.1 is E7018-1H4R. So this is a AWS classification, and each and every letter in this classification signifies something. So what does it signify? You can say in the classification 7018, the type of covering is low hydrogen potassium iron powder covering. It is suitable for welding in positions like flat, vertical, overhead, and horizontal. So it is all position wire. And it also indicates the type of current in which it can be used. It can be used in AC polarity as well as DC electrode positive polarity. So this is the classification for E7018. Likewise, there are different classifications: 6010, 6011, 7018, 7024. All those different types of classifications are there. So this is potassium basic type used for these positions. And based on the AWS classification, 70 indicates that it is a 70 KSI type of electrode in which the minimum tensile requirement is 490 megapascal, which is 70 KSI, and yield requirement is 400 megapascal, which is 58 KSI, and elongation is 22. So this table 2 in the AWS 5.1 indicates the property mechanical properties requirement for 70 KSI category. If it is 60, if it is 80, then the type of mechanical requirements are different. Then, yeah, this is the one. Then 1.8 indicates the electrode designation in terms of usability or in terms of the coating type. Okay. Then when we say that additional -1 is there, -1 is nothing but an additional impact property requirement.
Kita berikan pas yang banyak biar bisa.
So the 7018 requirement for impact is 27 joule at -30 degree, whereas when we say -1, the impact requirement is 27 joule at -45 degree. So additional impact requirement at lower temperature is indicated by -1. In the similar way, H4R indicates that H4 is the diffusible hydrogen level, means this electrode is designed to meet the requirement of diffusible hydrogen level less than 4 ml per 100 gram of weld deposit. And R indicates that the coating itself is a moisture resistant coating. So the moisture content in the coating is less than 0.15%. In that case, it can be classified as H4R classification. So the total classification is E7018-1H4R. So this completely indicates the mechanical properties, impact properties, diffusible hydrogen level, coating type. Okay, so it gives you the full picture what this electrode is capable of and what is the type of this electrode. Similarly, when we talk about the stainless steel electrodes, the electrodes are classified as based on the chemical composition, generally based on the steel base material which are suitable or matching with the chemical composition of this electrode. Then different coating types are classified based on their usability designation. Most common is -15, -16, and -17. -15 is basic coated electrode, -17 is rutile or acidic coated electrode, whereas -16 is in between. It is a basic rutile type in which there is a mix of basic as well as the rutile flux components. So I have already explained to you the effect of selection of different types of coating for different stainless steel material. Then how do we store and how do we handle these electrodes? Each and every consumable supplier have different recommendations in terms of storage guidelines and rebaking or re-drying recommendations. General recommendations are it should be stored in factory supplied condition without tampering the original packing. It should be used with first in first out basis. The storage room should be having a controlled temperature and humidity level. General temperature recommendation and humidity level depending upon different types of products. It should not be in direct contact with the walls or the floor. Okay, then the temperature should not be too low because there is a possibility of condensation, and it should not be too high also. The open package or the package once open, the electrode need to be stored in a drying furnace, and the temperature depending upon the recommended by the manufacturer of the products. Then one thing to highlight here is that cellulose electrode, they must not be re-dried. They should be used in as it is condition because the cellulose have some hydrogen or the moisture content which is necessary to get the desired arc intensity. Now coming over to our product range, we in Voestalpine Bowler Welding, we have a complete range of welding consumables for all types of materials. So when we talk about the welding processes, we have the covered electrode for SMW, T-rod, solid wires for MIG-MAG process, as well as the solid wire for SAW. And we have the complete range of flux core wire. Then SAW flux core wire are also available. In this SAW flux core wire, instead of the solid wire, we use the flux core wire along with the additional flux. Then solid SAW wire as well as the SAW flux are available for the complete range of materials, starting from the steel with 460 MPa, then pipeline material, then the welding consumable for steel with yield strength less than 460 MPa, creep resistant steel, martensitic stainless steel, ferritic stainless steel, austenitic stainless steel, dissimilar metal joining, and some special applications. Then heat resistant stainless steel or nickel alloys, duplex stainless steel, super duplex stainless steel, nickel alloy, aluminum and titanium alloys. So this almost covers everything. Even the cobalt alloys are also available in our range, which are in general called as stellite material. So you can see that the Voestalpine Bowler Welding product portfolio is a comprehensive product portfolio in which almost all the requirements which are from the industry are covered. That's all from my side. If you have any questions, please feel free to ask before we go for some surprise questions.
Okay, sir. Thank you for the material today. On the next schedule, we have a question from Mr. Rosan to participant, but it is for souvenir to you if you can answer the question of this. Pak Yusuf, please give the question for 3 participants can answer the question.
All right, Bu.
After this, we will to the next segment is a question and answer by Mr. Rosan. Okay, Mr. Yusuf, please.
Okay.
Should I?
So can you share, Mr. Roshan,
Okay.
first slide?
So the first question is, which of the following type of coating is generally more suitable for welding in vertical down position? Your options are A, basic, B, cellulosic, C, rutile.
So everyone who can answer, please raise your
Raise hand.
If you have listened to my presentation, I have already covered this topic in the
Yes,
presentation.
it's easy, Mr. Rosan.
Yeah.
Okay, who can answer this question? We will give you a souvenir from us to you if you can answer this question.
Silakan Bapak-bapak, Ibu-ibu. Pak Syahrial, option B.
Option B, cellulose. How about the answer?
Anybody
Yang
already
lain?
answered?
This is correct. Pak Sario answer B and Pak Sandro answer A.
The answer B is correct answer.
Okay, B is a correct answer. So the Mr. Sarial, we will give you a souvenir and we will contact you. And then second question.
Okay, moving over to the next question. Question 2 is, what is the product form with exact type for the classification AWS A5.4 E316L-15? So you have to select the correct description for this type of classification. What is this? E316L-15. Option A is TIG rod for 316L type base material. Option B is filler rod for GMW process. Sorry. Wait.
Okay,
This is
Mr. Hendy. Mr. Ramaya answer A.
Okay, then next option
That's
is
correct.
rutile coated stick electrode for SS316L type or basic coated SMW electrode for SS316L type. So yes, what is the correct answer? Anyone?
Yes, Mr. Ramaya answer D for number. Oh, this is for number 2. Yeah, answer A.
Who answered B?
No one.
Pak Sandro.
B. Oh, Pak Sandro answer B.
Which B? Actually, there is a typing mistake. So can he mention which B? Rutile coated stick electrode or filler metal for GMW?
Okay.
Yeah, which
Nomor
one
2
is the
dulu
answer?
ya Pak. Ini jangan dulu pada jawab nomor 3, nomor 2 dulu. Okay, the answer is Mr. Rosan.
The correct answer is basic coated SMW electrode of SS316L type.
L type. Oh, D. Okay, the
D.
correct one is Pak Hendri. Pak Hendri Mas Yadi Putra. Pak Hendri nanti kita hubungi kembali ya Pak untuk souvenirnya. Okay, number 3.
Congratulations.
Ya, nomor 3 we will start ya. Yang jawab setelah dibacakan soal tidak berlaku ya. Kita bacakan dulu soalnya, setelah itu silakan Bapak-bapak menjawab. Oke, the answer is number 3, Mr.
The answer is D. SW.
B.
D.
B,
SW.
Mbak. SMAW.
SAW, Samajak
SMA.
Welding, D.
Oke, siapa
Pak
barusan
Edo
yang
ya.
jawab? Boleh open cam yang barusan jawab, Pak?
Andra, Mbak. B, SMAW.
Oke, baik Pak.
No,
Nanti
the correct
kita.
answer is D.
The
SAW.
correct answer is D.
D.
SAW.
SAW.
Yes. The correct answer is D.
The answer is D. Yes, away. Yeah.
Oke Pak, yang jawab nomor 3 D kita akan kirimkan souvenir. Jadi semua betul ya. Di sini ada Pak Husni, Pak Aswinur, Pak Oldi, Pak Oki, Pak Mujianto. Nanti kita kontak kembali untuk mengirimkan alamat untuk kita kirimkan souvenir. Pak Yusuf nanti dibantu dicatat ya. Terima kasih untuk sesi materi dan juga sesi kuis sudah terlaksana. Sekarang kita lanjut ke sesi berikutnya yaitu sesi tanya jawab. Tadi di dalam chat sudah ada beberapa pertanyaan. Mr. Rosan, this is a question for you. We will discuss about the answer of this question. The first question is from Pak Azwinur. Welding copper material with SS 316L using GTAW welding. What is the best suitable type of filler rod use?
See, this is a dissimilar joining of stainless steel with copper. Generally, when
Yes.
we say that joining of copper with stainless steel or any other material, it is not very easy to join copper with stainless steel. The main reason is the thermal conductivity of the copper is very high, and also the melting range of copper and stainless steel is there's a wider variation. Okay, so because of that, the welding is not generally preferred for joining copper with stainless steel. Okay, the most common method used for joining of copper with stainless steel is the brazing process. So there are different welding consumables and different not welding, but brazing consumables and brazing processes available for joining of such material. Okay, if you want to have the technical details about such topics, I mean, we have a welding, we have our website, Hostelpine Bowler Welding website, wherein there are different topics covered, which are like specialized topic, which you can find from our website. Okay. And
can you
you
type
can
the
see
website here, sir? On your slideshow?
Yeah, this is the website.
You can type the link.
Yeah, you can take screenshot.
Okay.
This is our website.
Okay.
So there are different topics covered, technical topics, selection of welding consumables for different base material type, different applications, different segments you can find on this website, like power generation, thermal power, nuclear power, all those topics, oil and gas upstream, pipeline, downstream. There are brochures and catalogs also available for different topics from our website. Okay, and these are free to download from our website. You can find a different welding consumables also, welding equipment, personal protection equipment, accessories, automation. These are also, say for example, you want to find a welding consumable. welding consumable, brazing consumable, and finishing chemicals. Finishing chemicals are nothing but the pickling and passivation solution. Okay, then brazing solution are also available. Welding consumable, for example, you want stick electrode, T-rod, solid wire, all the different types are mentioned. You go on the stick electrode, there will be different options. What type of stick electrode you want? Mild steel, pipeline, low alloy type, stainless steel, multi-purpose, nickel alloy, protection. You go to low alloy. These are the different product names, their short description, then AWS classification, EN classification, what are the different approvals available for this, and you can download the product data sheet from this. Also, the safety data sheet can be downloaded from here. You click here, then it will generate a product data sheet.
Sorry, on the screen cannot not show your website, sir.
You see here the product data sheet EN in English.
Maybe you
DE
first
means it
to
is in
stop
German.
your screen share and then
Yes.
open your website.
Oh, you cannot see my website?
Yes,
Oh, sorry.
we cannot see.
Okay. Let me share again.
Okay.
Can you see now?
Yes.
So we went to our website. This is the website address I have mentioned in my presentation. You open that website, you go to the product, welding consumable, then go to welding consumable. What type of welding consumable you want? T-rod, stick electrode, solid wire. Okay, all these are here. You go to stick electrode. Then it will open this page. It will ask what type of stick electrode you want. Mild steel, pipeline, low alloy steel, stainless steel, multi-purpose, nickel alloy, wear protection, special product. You go to low alloy steel. There are different classifications, different types of product name, their short description, AWS classification, EN ISO classification, approvals which are available for this product. Then the data sheet can be downloaded from here. This is in German, this is in English. Then safety data sheet also available. So if you click, for example, here, it will open the product data sheet. You will see the product data sheet. You can download from here also. This is free to download, and you can find the complete information about this product. So in the similar way, there are different products with a different classification. Okay.
Oke, sir. Gitu Pak Aswinur, jawaban dari Mr. Rosan karena pengelasan Cooper dan 316L sangat sulit ya dilakukan. Biasanya yang dilakukan adalah menggunakan bracing proses. Begitu ya Pak. Oke, next question is from Chandra Sitorus. Mr. Chandra, why is the welding consumable selection factor not based on the strength the welded joint to be made?
Sorry, can you repeat the question?
Why is the welding consumable selection factor not based on the strength the welded joint to be made? Mr. Chandra, maybe you can ask directly to Mr. Rosan what your mean of the question. Oke, Pak Chandra masih ada? Pak Chandra boleh ditanyakan langsung maksudnya dari pertanyaannya bagaimana ya? Karena tadi di dalam materi untuk pemilihan welding consumable salah satunya Salah satunya menggunakan strength, apa namanya, kekuatan dari materialnya ya Pak, gitu. Oke, jika tidak ada, we skip to other question.
If I understand this question correctly, let me
Yeah.
answer. If I understand correctly, he's asking why the welding consumable selection is not done on the strength criteria of the weld joint. Okay, the question, it is already considered, the weld joint strength is already considered when we select the base material and the welding consumable. Like you see here in the point number 2, mechanical
Okay.
testing. The mechanical testing means when we select the welding consumable, we already consider the mechanical properties or mechanical properties of the base material. Okay, so when we say that electrode or mechanical properties, so the
Yes.
mechanical properties of base material are already fixed when you have decided the base material. So when we select a welding consumable, we select based on the matching or slightly over matching mechanical properties of the welding consumable as that of the base material. So when we say
Yeah.
mechanical properties, we already mean that it is the tensile strength, yield strength, and ductility and toughness. So
Yeah.
these are already covered. These are already considered.
Yeah. Okay. Okay, sir. Thank you. That is the answer of your question, Mr. Chandra. And then next question is Pak Syahrial Cahyanto. How do you specify the electrode for problem steel? I have the issue of identifying the materials due to unclear mill materials, given the fact that doing well ability is most likely a failure.
Oh, okay. See, in such case, I mean, when you do not know the exact chemical composition of the base material, it is, I mean, it is sometimes difficult to select a suitable welding consumable. So there are two options, like first is you do the chemical analysis of the base material itself and determine what type of base material it is, whether it is unalloyed material, low alloy material, what are the alloying elements present. When you get the chemical composition of the base material, then you select a suitable welding consumable which is closely matching to the chemical composition and the mechanical properties of the base material. Now, like when you say that there is a crack generated during welding, then the most common reason for such crack generation during welding of such base material, unknown base material, is that it may be a high carbon containing base material, and when you do the welding without following a proper procedure, then it is highly possible that the cracks may be generated in the welding. The reason is if the base material has very high carbon content or very high level of impurity elements like phosphorus and sulfur and other tramp elements, then they will segregate during solidification and they can cause a cracking with further tramp elements. But when the high carbon content is there, then the during welding, due to presence of very high carbon content, the hard phases will be formed, like Benedict phase or martensitic phases may be formed due to rapid cooling of the base material, and such difference between the microstructural phases from the unaffected base material to HAZ and the weld metal will lead to generation of hard phases, and that could lead to cracks generated due to welding. So in order to avoid such failures, first you have to do the chemical analysis of the base material, determine what are the constituent or composition of the base material. If the carbon content is very high, then generally it is not recommended to weld such material. If the carbon content is moderately lower and it can be welded, I mean, it has to be determined based on the calculation of carbon equivalent. Okay.
Yeah.
So if the carbon equivalent is manageable on the higher side, then slightly higher preheating temperature is recommended, and maintain slightly higher interpass temperature so that cracks may not be generated. So these are the possibilities. There are certain specialized electrodes are also available, which can be used for joining or welding of such unknown material.
Okay, yes, sir. Thank you for the answer. There is the answer from Mr. Rosan Pasarial. We have another question. Question again, Mr. Rosan. In regards to dissimilar metal weld, how do we utilize diagram scaffler for research purpose? Do engineers yeah? Hello, sir?
Sorry, can you repeat that?
In regards to dissimilar metal weld, how do we utilize diagram scaffler for research purpose? Do engineers in status quo still use this diagram to determine the chemical composition of the electrode, or there any other alternative to option electrode?
Sorry, can you specify which diagram?
Scaffler diagram.
Oh, Schaeffler diagram. Oh,
Yeah.
okay. Schaeffler diagram is for the stainless steel material. Okay. The Schaeffler diagram is gives you an idea about what type of microstructure you will get based on the chemical composition.
Yeah.
Okay. So I mean, if you ask for the practical application, I don't think it is. I mean, it is of that much use, because when you have in the commercial application, when we specify that the particular grade of stainless steel, say for example 316L or 304L material is determined, then it is already having a certain range of chemical composition based on which the microstructure is already decided for the base material. So 316L is like, or 304L, these are austenitic material with having the majority of austenitic phases with some percent of ferritic or the delta ferrite present in it. So this is how, I mean, it is already decided for the research purpose or the development of new material. Maybe it can be used on the regular basis, but as a welding engineer, it is of limited use to us in terms of determining the welding consumable.
Ya, baik, sir. Begitu Pak Syarial. Jadi untuk kepentingan research purpose ini bisa digunakan ya, karena dengan kita menggunakan Scaffler diagram, kita juga bisa memprediksi fasa yang nantinya akan terbentuk. Begitu. Kemudian the last question from Pak Aswinur again. Does EWL Lantalum 2% tungsten electrode replace EWTH 2% electrode in GTAW for stainless steel welding? It can replace from EWL Lantalum 2% to EWTH TH2% electrode?
Yeah, it can be replaced. See, thoriated and lanthanated, 2% thoriated, 2% lanthanated. These are the type of non-consumable electrode and I mean tungsten electrode in the UKW process. Lanthanated, I mean thoriated can be replaced with lanthanated without that much effect on the welding behavior or the arc properties. In terms of the acceptance as per the qualification criteria as per ASME section 9, I'm not so sure whether it is accepted or whether it is the essential variable or non-essential variable. That one we need to check. But for the technical perspective, yes, it can be changed.
On the technical aspect, it can change. But Mr. Aswinur, consider about the radiation safety.
Yes, nowadays what is
Yes.
happening, the thoriated is being replaced because thorium is slightly radioactive in nature. So the red one is being replaced with the lanthanated one.
Okay.
Yeah.
Okay, sir. Thank you for the answer, Mr. Azwinur. Begitu jawabannya, jadi bisa digantikan secara teknikal dan juga dengan alasan safety juga ya, sangat baik bila digantikan dengan yang menggunakan AWTH 2% electrode. Kemudian pertanyaannya sudah semua terjawab.
Ada yang belum, Bu?
Ini ada dari siapa, Pak Sandro ya?
Tadi Pak Husni dulu.
Oh, Pak Husni. Yang Pak Husni, Pak Husninya masih ada
itu,
nggak
Pak?
ya? Oh ya, how to adjust the current and voltage in the butt weld process of flat object with different thickness from 12 mm thick plat, 6 mm thick plat. How to adjust the current and voltage in the butt weld process? Maybe the best voltage and current with different thickness, sir.
See, there are general recommendations from the welding consumable for different thickness and different material grades as well as the different diameters of electrode. So, and with the use of those recommended parameters, you will get the optimum weld penetration as well as the width of the deposited weld metal in butt weld depending upon the welding position. So there are general recommendations, but most commonly for different grades like stainless steel, carbon steel, low alloy steel, the normal range is also mentioned on the welding electrode packets. Like when we supply the bowler product, we also mention the recommended range of welding parameters in the label itself. And also, if you see the product data sheet, like just now I have shared the product data sheet. You can see here for this product. This is the AWS classification, general description, what are the base material mentioned, typical chemical analysis and mechanical properties, the operating data including what are the positions it can be used, like vertical up, not suitable for vertical down, porosity, DC minus, what are the designations which are mentioned on the electrode, then redrying conditions, approvals. It also mentions the recommended amperes for this product for different diameters and length. Like for 2.5 millimeter dia, 80 to 100 amps is recommended. This is the optimum range. 3.2 millimeter dia, 110 to 140. So 4 millimeter dia, 140 to 180. 5 millimeter, 190 to 150. So these are the amperes recommended for different diameters. Voltage is not mentioned here because the voltage for SMW electrode will depend upon the arc length. So, or we can say the stick out or the distance from the base material to the end of the electrode. So if it is too high, then voltage will be higher. So it is a constant current type of process. Voltage is always fluctuating. So voltage has to be determined to keep as close the electrode tip possible to the base material. So this is how it is to be done, and you qualify the procedure to do the testing. If it is meeting the requirement, then prepare a WPS within those qualified parameters so that it will give you the similar results in the actual fabrication also. Hope this clarifies.
Okay, sir. Thank you for the answer. There is the answer for Pak Husni question. And next, this is the last question. Can stainless steel such as 253 MA is welded use filler metal AWS A5.34 for flux core arc welding process? Because I see in the ASME 9 for stainless steel with FCAW welding process only can join by AWS A5.22.
See, 253 MA is a trade name of the base material, which is a type of stainless steel material. Okay.
Okay.
And this is not, I mean, the standard grade it is there in the ASME or ASTM material. The typical composition for this material is around 20 or 22% of chromium and 10% nickel with some percentage of nitrogen in it. And when he says that this is a stainless steel material, okay, and there is no exact matching classification as per 5.22. Okay, 5.22 is the filler metal classification for stainless steel FCAW. Also for SMW as per AWSA 5.4, there is no exact matching chemical composition of filler wire for this base material. But if you say about EN ISO, then there is an exact matching grade as per EN ISO 3581-A. And he's asking 5.34 is for nickel base. So if you use the nickel base flux core wire, then it will be a overmatching selection of base filler material for lower grade of base material. So if you are okay with that in the cost point of view, then I think should be okay. But generally, the closest matching stainless steel wire or stainless steel electrode will be more suitable, which is having around 20-22% chromium, 10% nickel, and 0.15 or 14% nitrogen content. Those products will be more closer suitable for this type of base material. Okay. In Bowler, we have suitable welding electrode, which is specially designed for 253 MA base material welding.
Okay. Yes, sir. Oh, we have one question from Pamuliana. We have any time, still have time, Pak Yusuf? for one question?
Masih.
Okay. This is the last, Mr. Rosan. And for the participant, this is we close the question for you all. For the last from Mr. Mulyana, if we want to do welding on gear teeth, product material is SKD 11, hardness 50 to 60, hardness Rockwell after hardening.
Yeah.
Is it need to do annealing process first, or we can directly doing welding without annealing first?
Okay, one question. This hardening is done by hard facing welding, or is it done by case hardening?
Pak Mulyana not mention about that. Mr. Mulyana?
Okay. Okay, so I explain first ya. Thank you
Okay, Pak.
for the time ya, Mr. Rohan ya.
Okay, please, Pak.
Can I ask directly to you ya?
Yes, please.
Okay ya. The condition gear is full hardened. Yeah. The size is around maybe 1000 mm. Because this is a kind of high speed gear, yeah. So so I need the high hardness, yeah. Okay. I found the problem. This is a little crack, yeah, on the teeth, yeah, and then I want to do welding, yeah, on that. So what do you think about the procedure of welding? Can I directly doing welding on the surface, yeah? And what kind of the electrodes can use, yeah? Or we can do an annealing process first, yeah, to this part, yeah, before we do welding. Next step, doing welding on the surface. I think I like that, yeah. So can understand about what I mean.
Yes.
Thank you.
So in this case, it is a case hardening. The hardness of the gear teeth is 50 to 60 HRC. See,
Yes.
in such case, you can do annealing also, but there are products which can directly be used for crack repair of gear teeth. Okay, but it is not straightforward just do the welding, because this is a tricky, not tricky as such, but we need to take some precautions for rebuilding of the or the repair of the cracks in the gear teeth, and the final hardness requirement is around 60 HRC. So generally what happens, you grind the crack area, okay, you remove the crack, you do the dye penetration test to make sure that the crack is removed completely. Then in most of the cases, we recommend to do the buffer layer using the softer material for build-up. Use the buffer layer. Mostly one or maximum two layers are good enough. And if the deposition thickness requirement is too high, then we also recommend to do additional build-up with slightly higher hardness welding electrode. But if the deposit thickness is not much, then one or two layer of buffer layer, and final hard deposit can be deposited on the previously deposited buffer layer. So we have a wide range of products which are suitable for such applications in our tool steel category, and depending upon the hardness requirement, and we can recommend a suitable product. So 50 to 60 HRC we can achieve in the final hardness or the deposited weld material. Why do we need to do the buffer layer? Because we do not want to generate more cracks during welding with the hard phases, because in such material there is a possibility of generation of cracks during welding when we deposit the hard phases or the hard deposit on the hard material itself. So just To give a cushion, we provide a buffer layer, then deposit a final hard material. So that is a generally recommended procedure. And case to case basis, the selection of the buffer layer electrodes and the final hard facing electrode may vary. But yes, it is possible to do that, and it is not very uncommon application. It is very commonly used in the industry, and the electrodes or the wires are easily available for such application.
Oke. Oke, Sir. Pak Mulyana, jadi disarankan menggunakan buffer layer terlebih dahulu, kemudian baru nantinya dilanjut dengan hard facing layer gitu ya. Oke, Sir, thank you for your answer. This is close for our discussion segment. And the next schedule or agenda is to closing our webinar event. Thank you for coming for you all participants. And then thank you for Mr. Rosan for your knowledge sharing session for today. We hope we can join to another session of webinar on the next schedule in Welding Study Center. Okay, for you all, please open your cam to photo session.
Silakan Bapak mohon open cam, kita foto bersama dulu.
Oke, dihitung dulu ya Pak Yusuf. Silakan.
Oke.
Satu,
Tahan Bapak, tahan.
1, 2, 3. Oke, next slide. 1, 2, 3. Oke. Baik, acara webinar kali ini sudah selesai. Terima kasih atas partisipasi dari rekan-rekan sekalian dan juga adik-adik sekalian. Semoga kita bisa ketemu lagi di webinar session berikutnya dengan materi-materi selanjutnya yang lebih menarik tentunya di dunia kita, di dunia pengelasan, dunia inspeksi, dan juga dunia safety. Terima kasih atas kehadirannya. Wassalamualaikum warahmatullahi wabarakatuh. Mohon maaf kalau
Terima
ada
kasih.
Waalaikumsalam.
Waalaikumsalam warahmatullahi
Thank
wabarakatuh.
you.
Thank you,
so much.
Mr.
Pamit izin
Rosan,
live.
for
Thank you
your
so much.
time.
Thank you.
Thank you so much.
Halo, Mr. Chandra.
Ya, Ibu. How are you, Ibu?
I'm fine. Where
I
are
still
you now?
you remember